MATLAB stores all types of data in arrays. This includes not only numerical data, but data of other types such as strings and even complex objects. So working with arrays is fundamental to working with MATLAB. We will look at how with the MATLAB language you can create arrays, access and assign values to array elements using a number of indexing methods, and perform many other operations to manipulate the array's contents. Let's first look at creating arrays. You can create an array by specifying specific values, using square brackets with commas or spaces to separate them. And use semicolons to separate rows. You can create equally spaced one-dimensional arrays with the colon operator, such as 1 to 10, or 1 to 10 in steps of 2, or 10 to 1 in steps of -2. The linspace function is similar to the colon operator, letting you specify a start and end value, but also gives control over the number of points, such as 7. You can change rows to columns with the transpose operator. You can also call a number of functions that generate elementary matrices with different contents, such as 1s, 0s, or random numbers, such as rand. Here we'll specify 6 rows, 4 columns. It can be more convenient to inspect the contents of an array by opening it in the variable editor. Let's now look at how you access and change the values of array elements with different forms of indexing. You can specify elements of an array by simple row and column indexing. Here is the element in the first row and second column of A. You can specify a range of rows and columns to access sections of an array, such as row 1, columns 1 and 2. The elements do not have to be contiguous, such as row 1, columns 1 and 3. You can specify all rows or all columns by using the colon operator on its own. In this case, all columns. You can also use the end keyword, like row 1, column 2 to the end, or column 2 to the end -1. You can assign values to specific elements by specifying indexing on the left-hand side of an equation, such as row 1, columns 2 to the end -1 equals 10, 10. You can delete one or more rows or columns of an array, such as rows 1 to 2, all the columns, by assigning it to the empty matrix, denoted by square brackets. A is now 2 rows shorter. Sometimes it can be convenient to treat two-dimensional arrays such as these as a one-dimensional array, as though all the columns were stacked together into a single column, and specify a single index. This is called linear indexing. For example, the element at row 1, column 2 in A can be specified with a single index, A5. This is possible because MATLAB arrays are stored column-wise in memory, i.e. each column in the array is stored one after the other. So the element at row 1, column 2 is in fact the 5th element stored. As the colon operator used on its own specifies all elements, when used with linear indexing, it returns a single column vector with the entire array contents. You can also access elements with what is known as logical indexing, where you specify an indexing array of equal size filled with true or false values, like a mask. This is useful for operating on array elements that match some criterion, such as A less than 0.5. This creates an array of logical values the same size as A, with true values displayed here as 1 wherever A is less than 0.5, such as here. You use logical arrays like this to perform logical indexing, such as set all the elements of A, which are less than 0.5, to equal to -1. To find the actual indices of array elements that match a criterion, use the find function, which finds non-zero values together with the logical expression. By default, this gives the linear indices of the elements that meet the condition. You can also get the row and column indices instead. You can find out about all indexing techniques by looking in the documentation. And finally, let's look at how you can determine some useful information about an array and perform other basic operations. You can determine such things as if the array is empty, get the length of the array, or the longest dimension, used usually for one-dimensional arrays, the size of all dimensions, and the total number of elements. As we saw before in creating arrays with specific values, square brackets can be used to concatenate any number of arrays together, either horizontally or vertically. Other useful array manipulation functions include flip left right and flip up down to reverse the order of elements, repmat to replicate arrays, reshape, and sort. Although the examples shown here use one- and two-dimensional arrays, most of these techniques can be applied to multi-dimensional arrays as well. See the documentation for more information. This concludes the demonstration. Try these features in MATLAB now, or watch one of the other videos.